on either 12 or 13. Okay, whatever it matches in your lecture. Maybe 13, right? Friday? Friday, not this Friday, the next Friday. Okay, your test will be, test 1 will cover whatever we discuss until this week. In this class and the next this lecture and then Friday lecture. Okay, then module 1 to 3. Okay, then test will be written and no MCQ. Just bring your pen and pencil. Okay, please make sure that if you use pencil, please make sure that your pencil is dark enough. Actually, whenever you write, we will give you exam paper, okay, test paper. So then you need to write in, and in your test, you cannot open your computer or anything. You cannot use your headphone or earbud or anything. Your test. Okay, so if you do not appear for the test, test 1 or test 2 or test 3, then your final will be compensated. Final test will be used to compensate this. Okay, but if you come into the classroom and see the test and return it, even if you got 0, then you will not be compensated. Okay, like everybody to take the test, so you will be prepared. Your final exam will be cumulative, so everything from the beginning to end, and more sometimes you will see some similar questions or repetitive something similar from previous test. Okay, today we will discuss selection structure, and I believe from this lecture you will get interest on programming, and this is the actual startup. So people who are new in programming, I think you should get interest from today's class, this lecture. So selection structure, as we discussed, the structure or skeleton of a program, and we also discussed some sample programs, right? Sample and simple programs, right? So unless otherwise, what happens? Our program scores are executed from the beginning, line by line, and each line is executed one time. Okay, and every time you start you compile, you run your program, it will be running as a fresh copy. All of your previous data will be gone unless you use persistent database, that we are not discussing how to connect with persistent database in this program. So we'll be using local variables. So I think so far we discussed how to print something, how to print something in Java, in C# and in C++, and how to use scanner class or scan loop using keyboard, and how to display that, right? And we was in our previous lectures we discussed operators. We know that there are two kinds of operators. Mainly operators are two major kinds, unary and binary operators. So we discuss unary operators and we discuss binary operators, one kind of binary operators, arithmetic operators. Okay, we focus on module operator. There are some types of operators, relational operators, logical operators. We will discuss this in this section, and we will see their implementation. Okay, so that's what I was telling. Unless otherwise, program code will be executed from the top line, and one after another. On each of this line will be executed only one time, right? But sometime we may need to repeat the execution of a statement more than one time. That is repeat statement. We will discuss that after this module. But for now, let us discuss that what happens sometimes we work with conditional statements. Some statements are conditionals. For instance, in our natural language, English language, spoken language, we say sometimes, if you come to my place, I will go to your place. I will go with you, right? So this is a sentence if plus present plus future in this format in English. That means there is a condition here. If you come here, but if you come to my place, then I will go with you. It does not say, it infers that if you do not come, then I will not go, right? That is optional. It infers, right? Similarly, in program statement, in order to execute that kind of statements, we use if statement. Okay, we use if else. What happens? We use if in order to give a condition. If our condition is fulfilled, then we will do something. Okay, so then what happens if the condition fails? If the condition fails, then we will use the else block in order to execute something else. Okay, if there are multiple conditions, then we will use if, else, if statements. There is another, these three are the version of, these three are the version of if. And there is another is switch statement. Okay, alternative to use. So we will see this. Let us see if we can cover these first three, if, else, if, and if, else. If, else, if, else, and if, else. Okay. In order to execute all of these conditional statements, okay, we need to use a conditional expression. Okay, we will go through this conditional expression, but Boolean expression. But let us see this. This flowchart. This flowchart, it says it has a starting point, it has ending point. So this seems to be a flowchart, complete flowchart. And actually, this is a conditional statement. Okay, it says, did you break anything? Okay, this is a question. Okay, so it will give you a result either true or false. Or in English, it will give yes or no. So if my answer is yes, then it will go direction, and if it is no, then it will go through another direction. And you see all of the diamonds, these denote our conditional statement in our flowchart. Okay. And this arrow, it shows the program direction. Okay, based on my result, yes or no, the program flows in one direction or another direction. But in programs, okay, now we want to understand how to implement this block diagram in a actual programming language. For instance, we want to implement this kind of flowchart or problem. This is an algorithm, right? Okay. It's depicted through a diagram. We want to implement this kind of algorithm in a real program. Here you see all of the diamonds. These denote conditional expression. So then now the question is that what is a conditional expression, or sometimes it's called Boolean expression. Okay, a conditional or Boolean expression that gives a Boolean value. So a Boolean value that is either true or false. not both at a time. Either true or false. It's a Boolean value. Okay. The concept of Boolean algebra or Boolean value, okay, came from the concept of electricity. You know, the electricity all switches and these have two states, either off or on. Right? Either off or on. There is none in between. There is nothing in between, right? All electric switches have two states. Either true, that means either on or off. By on, we want to mean true. Off, we want to mean false. That means in other ways we can say true is number one and false is number. If there is some electric power passing, then we say 1. Now no electricity is passing, then we will say 0. 0 volt or sometimes this Boolean expression can be very simple or it can be very large or sometimes large. Whatever the size is, your final result will be either true or false. Okay. So based on those final results of a Boolean expression, we will use our this selection statement: if, else if, or switches. These three. Okay. So now let us see a Boolean statements in detail, but in okay. So this is a Boolean statement. This is a Boolean statement. Okay. So actually, before I discuss this, let me discuss another kind of operators. These are called relational operators. Relational operators are binary operators. Okay, that have this relational operator has used two operands as said. Okay? One on the left side and another goes right side. Okay, this we know this. This is greater than sign. This is less than sign. This is be give attention to this one. Two equal sign. This is the equal relational equal. This is the actual equal operator we will use in programming. Previously, we operator only one equal sign, that was assignment operator. Okay. But this is the relational equal operator. Okay. It will tell whether two operands are same or not. So this is maybe this looks maybe not new to some of you. So this is called relational not operator. So what it does, it will inverse true or true false or false to true. So if you say not true, that means false. If you say not false, that is true, right? Okay, so and this is not equal and this is greater or equal. Remember that the word or, not and. Okay, and this is less or equal. Okay, these are the common symbols. Everybody should be familiar with this and we will go through this. So let us check the result. What will be the result of this expression? And as I told you that a relational operator will true or false value. Nothing else. Either true or false, not both. Only one, okay? So 5 is greater than 3, right? The result will be true. Okay, so then 6 not equal to 6. We know that 6 equal to 6, right? So this will give us false value. So that how about this one? True equal 4 is or equal to 2. What will happen? It will be executed fast. So it will be checking that is 4 less or equal to 2? No, right? This part will give us false result. Then it will be compared. Is true equal to false? No. So the final result will be false. For this one, maybe this one is something different. This is the character C. We encode something within single code, computer gets is ASCII value. Okay, so ASCII value, if you are familiar with ASCII chart, ASCII, ASCII table. ASCII means American Standard Code for Information Interchange. So these are the ASCII chart. If you go to images, my internet is slow. I should not go there. Okay. Okay, if you see the ASCII chart, if you check for ASCII chart, you will see that number A is the position or serial in 97 in ASCII chart. Okay, so number B, the letter B, so then the letter B will go 98 and C will go 99. So then it will compare whether 99 is equal to 98. Is false. Up, also not equal to. True. Okay, so this is not false, that means true, right? If you want to use pseudocode, then you will use this arrow sign in order to mean assignment operator. But using programming language, we will use equal sign. Okay, there is another kind of operators that are essential, that are called logical operators. So logical operators are related with logic circuits. So is anyone here is familiar with logic circuit? Logic circuit. If you are taking any course on electronics or electric, you should be familiar with. Okay. The concept of logical operators, we were discussing logical operators. Okay, there are three basic logical operators: logical not, logical and logical or. These are the three basic logic operators. Okay, so the concept of these logical operators is from the concept of logic circuits. Logical not is something, for instance, if you have a circuit, like this is denoted by logical NOR circuit. If you give an input to it, okay, whatever your input will be logical input. Okay, input, true or false. So for instance, if you give it 0, then it will return it. If you give it 0, if you give it input 0, then it will give you output 1. And if you give input 1, it will give you output inverse. Okay, so this is the simple of logical not operator. Okay, and there is another operator is called logical and. Okay, let me try to draw it. For instance, if you have what is happening here? Okay, for instance, if I have a battery over here, okay, battery over here, and I have a light over here. Okay. And if I have a circuit like this, there is a switch A and another switch, this is switch B. Okay, so think about situation. Electricity is passing from this way, battery to the light. Okay, so think about the situation, how the light will be turning on. So if I have both switch A and B are on, then my light will be on, right? So for instance, if I have this switch 0 off and this switch off, then light will be off, right? Off, right? And I have this switch on but this switch off, then light will be off, right? And if I have this switch off but this switch on, then light will be off, right? And in order to turn on the light, I need to have both switches on. Both A and B, or as many switches I do have, called series circuit, right? Series circuit. So as many switches I do have, all of this needs to be on. Okay, so that means A should be on and B should be on. So in our logical expression, we will say that A needs to be true and B needs to be true, right? So we are emphasizing the word and. So this is my AND operation, is like this. Whenever you see AND operation, then you remember this circuit in your mind. Okay. And the operator in most programming languages, you will use a symbol 2 ampersand together. 2 ampersand without any gap in between. This is used as logical AND operator. Okay. So the operation of logical AND operation is like this. If A is true and B is true, then result will be true. Either of these is false, the entire result will be. Now we understand the concept of Boolean logical AND operation. Okay, so let me try with another circuit. So if I have a battery, okay, for instance, I have my battery over here, my battery, and this is my light. Okay. So, but if I have my connection is circuit is like this, I have my switch A over here, coming this way, and I have another switch B. Okay, please don't confuse about B, this B for battery and this B for switch. So as we know that if for this kind of circuit, okay, it is called parallel circuit. Okay, so if either of my switch A or B is on, then light will be on. If I say, for instance, if I have A and B and then L. If A equal to 0 and B equal to 0, then light will be 0, right? If A equal to 1 and B equal to be 1. If A equal to 0, light will be 1. Then B equal 1, light will be 1, right? And if both are 1, right? So the main word over here is or. Okay, so the concept of or operation is like this: either A or B. If it either A or B is true, then our result is true. So in most of the programming languages, this is expressed as two vertical bar. Logical operator is expressed two vertical without any space. So for instance, this one, this is the OR operation. In order to be true, the result of OR operation, either A or B, the operands, these are the operands, either of the operands needs to be true, not both. If both, then fine. So we will use these operators a lot for conditional and programming statements. Okay, so whatever I told you, that no matter how large your logical expression is, your final result of this part will be either true or false. For instance, in this case, if this is true, then it will be executing this, and if it is false, then it does not say what it will do. Actually, it will come here, next block. This is an execution result of a Boolean expression. You may be given an expression, you need to figure out the result of the expression. Okay, if it is a Boolean expression, then result must be true or false, nothing else. And if it is an arithmetic expression, your result will be arithmetic result. So in most languages, you see that all Java, C# and C++, we use these symbols. Is anything new to you so far? We are familiar with all of this, right? We discussed all of this, right? Okay. This is logical word, the last one logical and, this one logical and this is logical not. And these are the comparison or relational operators. These are arithmetic operator. So far we discussed this. You see that the high precedence. Precedence is that which operator will be executed first and which one is will be executed next. The operators with lower precedence will be executed later. If I find, for instance, if I find an expression, so then how expression will be executed? We know that this part with parenthesis has the highest precedence, right? So this one will be executed first, then the multiplication sign, then the addition sign, then the greater than sign. How actually it will be executed? This part will be executed first. The whole of this part will give you a result, right? A number. For instance, what it will give me? 3 plus 4, 7 times 35, 5 minus 1, 34, right? Right side is 34 and left side 4 times 4, 16 plus 3, 19. So is 19 greater than 34? No, so the result will be false, right? So this is how computer computes an expression. Maybe I discussed that curly braces are used to make lock. When we use indent. Okay, so now we are coming from an actual format of if statements. The logical expression or relational expression is given in the condition. Yeah. Okay, then the evaluation will come here, or the evaluation result will be either true or false. Based on true or false, it will execute this statement or skip this statement. How many minutes I do have left? 13. Let me see if I can use 10 minutes to discuss with a live program. So this is if, okay. So if has a condition within, okay, sometime in pseudocode format we will use then, but in actual some programming languages we do not use then. Like in natural language, we do not say then, right? If we do not say if you come, then I will go. Then is sometimes optional, right? We say if you come, I'll go. Okay, so this is a statement. Actually, what was okay? This was a problem. So I like everybody to, when you go home, discuss this program. Try to this program. It is converting temperature from Celsius, and you were giving output to Fahrenheit. Okay, so let us do an example. Oh my God. By the way, everybody is familiar with repl.it. Everybody has an account. Are practicing? Okay, if you wish, send me an email with your ID. Then I can see what are you doing. Okay, so we will use it in order to do some quick programming, but I recommend to use either Eclipse or Visual Studio or NetBeans. In order to develop professional program, we need to use those. Okay. Okay, so people are taking C# lab. Okay, let us go to a C# program. Selection example 1 C#. Okay, what we can do? Let us do a simple thing. We want to check whether number is an even number or an odd number. Very simple, right? Coming. C# selection. It is too slow. Okay, we don't need hello world, this line. Okay, for instance, I have a number integer. Let me do a quick hard-coded number. 5. Okay, I want to print whether this 5 is an even or an odd. Okay, please help me. Right line, the number plus x plus is even. What is the condition? I want to print this. I want to print the number 5 is even. What is this? How can I do that? I need a condition, put a condition over here, right? How can I check my number is an even number? If it is divisible by 2, right? How can I implement this in my program? If x modulo 2, it will give me remainder, right? What is my expected remainder? Equal to 0. Okay, then that means this statement will be executed. Okay, so everybody understand this? I can enclose this within another parenthesis, or I can keep it. If I let me run this. Unexpected symbol. Which line? Oh, sorry. Unexpected symbol equal. What is that? Okay. Let me keep it 4. Line 6. Oh, sorry, I did not declare X. I'm my mistake. Okay. Okay. You see that? Give thank you for your attention. Okay. So I wanted to print number 5 is even. Okay. So what do you think? Will I get my any output from this program? Yes or no? I will not get any output. What is the reason? Because my number is what? So my condition is false over here, right? So this statement will not be executed. Okay, so then how can I execute this statement? My statement must be made true. Oh. What is this allowed? Oh, sorry. Case chest allowed. There will be. Only a test, okay? Don't we don't need to go out. Good system, okay? So it is giving us. Go outside? No. Okay. Do you have 5 more minutes? I do have 5 more minutes, right? Okay. So okay, thank you. So in order to test this number, I need to make this true. So how can I make this true? Say not equal to. If I say not equal to 0, then my program will run, right? 5 is always is not true. Okay, so actually not this way. I will do. Let me do something like this way. Else okay, so if I write this way, so if this part is true, then this will print number is even, and otherwise I said else. That means if it is false, then it will be executing this line. Then it will tell me that the number x is what? Okay, so by this way, no matter however I change my number 5 to 50, okay, it will give me my expected result. 50 is even. If I change it to, instead of 50, if I make it 15, then still it will give me true result. Where did we implement our logical expression over here, or relational expression we put here, right? We put our condition over here. X modulo 2 equal 0. Then it will execute this, and if it is false, then it will skip this line and it will go to the even block. Okay, sometime if your block is only one statement, you need to give parentheses. Okay, not enclosing brace, but if there are more than one lines, okay, then you have to use. Okay. Now let us do something like this. Okay, so you see the last statement I wrote here, thank you. So it is not related to the state condition. Whether your result is true or false, we will get this statement. Okay. Now at this point, I like everybody to open your IDE practice. You know, this course is like a swimming course. Diving into water, no one can learn how to swim, right? No matter how many theory classes he or she takes. Okay, thank you so much, and I will see you on Friday.
Okay, so
Yes, sir.
can you go back to the slides? The question on operations, where it was 6 not equal 6.